Let's begin by defining again what we have learned in the previous sections. So we were told that dy is the differentials and delta y is equal to the increment. So if I put the formula, it will be like this. The increment is the y2 minus y1. It means that it related to the second line, the line that intersect at 2 points, and we can have it from the functions. We put the x and the delta x plus delta x into the functions, okay, into these functions, and then we'll get f of x plus delta x subtract with f of x. That's how we get y2 minus y1, and we'll get the value of the increment. And it's related also to the exact or the actual difference, okay, while dy on the other hand will be the approximations, and it obtained from the tangent line over here. So we have a tangent line, we make the derivative of it, and then times with the dx or the delta x. As the delta x becomes smaller, like what we have learned in the previous sections, then we can say that dy is approximated close enough to delta y. Okay, so let's bring this into the next sections, which is the marginal analysis. Over here we have the graph of cost functions, actually c of x, and as you can see that when we want to find the increment, okay, wait, the delta x is equal to 1, okay, the delta x is equal to 1. So when we want to find the increment, then we'll get, let's say that this is a c of x over here, this is a c of x, and then over here we get c of x plus with 1. So the increment will be equal to c of x plus 1 subtract with c of x. On the other hand, to get the differentials, then it will be equal to dy will be equal to c prime of x times with dy will be equal to c prime of x times with f of x. Okay, so we have this c prime of x times with dx equal to dy, while dx is equal to delta x equal to 1. So that's why we can say that the differential is c prime of x. So if you understand the increment and the differential on the previous sections, then it will help us to determine the next chapter, which is the marginal analysis. This is one of the important applications of calculus to business and economics. And in economics, the word marginal, it refers to the rate of change, that is the derivative. So if c of x is the total cost of producing the x items, then c prime of x, okay, c prime of x will be called as the marginal cost and represent the instantaneous rate of change of total cost with respect to the number of items produced. Similarly, the marginal revenue is the derivative of the total revenue functions, and the marginal profit is the derivative of the total profit functions. I'll show you the table. So this is the definitions. The total cost is c of x, the marginal cost is c prime of x. If the total revenue is r of x, then the marginal revenue is r prime of x. Same with the total profit, we define it as the revenue subtract with the cost functions. So when we get the marginal profit, it will be r prime of x subtract with c prime of x. And it's very important to remember that c of x represent the total cost of producing x item, not the cost of producing a single item. That's different. Okay, so to find the cost of producing a single item, we need to find the total cost of producing x plus 1 items subtract with the total cost of producing x items. In that way, we can get the exact cost of producing like x plus first item. Okay, so let's have this kind of problem. A company manufactures transmissions automatic transmissions for cars, the total weekly cost in dollars of producing X transmission is given by C of X equal to 50,000 plus 600X minus 0.75 X squared. Find the marginal cost functions. Okay, so again, based on the definitions, the marginal cost will be C prime of X, and we have learned how to get the derivative of it. 50,000 over here will be equal to 0 when you make the derivative, and 600x will be 600 when we try to make the derivative, and then negative 0.75 x squared, that will be 0.75 times with 2 times with x to the power of 2 minus 1 over here, the exponent, so it will be 600 minus 1.5x. B, find the marginal cost of at the productions level of 200 transmissions per week. So we'll get C prime of 200 equal to 600 subtract with 1.5 times with 200. So 1.5 times with 200, this will be 300. 600 minus 300, that will be equal to 300. Interpret the result of part B. So at the productions level of 200 transmissions per week, okay, the total costs are increasing at the rate of $300 per transmissions. Again, the interpretations of result of part B will be this. At the productions level of 200 transmission per week, then the rate will increase by $300 per transmissions. That's what it means. It's not the total cost, but the cost to produce the next item will be $300, something like that. Okay, so D, find the exact cost. When it asks us the exact cost, always remember that it refers to the increment. When you have the increment, you have y2 minus y1, while if you have the marginal cost, that will be the differentials. Okay, so the exact cost will be equal to C of 201 subtract with C of 200 if you want to find the items of 200 first cost. Okay, then C of 201 will be 50,000. Okay, 50,000 plus with 600 times with 201 minus with 0.75 times with 201 square. I'll just write it. Yeah, so and then subtract with 50,000 plus with 600 times with 200, subtract with 0.75 times with 200 square. This one is obtained from C of X, and then we'll get that it's equal to 299.5. Try to compare between the marginal cost and the exact cost. So it's only like 0.5, which is 50 cents. Yeah, so the difference is not that much if we try to approximate the marginal cost. So based on that, we can have the theorem 1, marginal cost and exact cost. If C of X is the total cost of producing X items, then the marginal cost functions approximate the exact cost will be this one, C prime of X. Remember, the differential is approximate to the increment, which is the exact cost. Yeah, so we have this. While we get that dx is equal to 1 in this case. Okay, that's why we have a plus first item. Take a look this graph. Okay, so this is a cost functions. In practice, the marginal cost is used more frequently than the exact cost. One reason for this is that the marginal cost is easily visualized instead of we have to get the exact cost. So if you have the exact cost, probably you'll have a messy graph, but that's not the only reason. Okay, but it's easily to visualize when you have, let's say, at the producing 200 items. Okay, you'll get that the slope is 70 it means that the next item will have $70 to make, okay. And when when the item is 500, okay, then the slope is at 40. So the cost function is decreased when you have that the production increase. Again, the production increase, the slope is decreasing. Why is that happen? So imagine if you have like a cake shop or a donut shop, like a I don't know, Bobby Donut probably, yeah. So if you have something like that, and let's say you produce one donut instead of 200 donut, the cost of producing one donut is much more expensive than producing the $200, not $200, I mean the 200 donuts. Yeah, I'm not trying to say the total cost, I'm saying this one. So let's say the cost of producing the first donut, and okay, this is just the functions. Okay, let's put it, let's say the first donut, that will be, look, 10,000. okay, yeah, quite expensive, yeah, for one donut is 10,000, but this just so we get the picture. Okay, 200 donut, you'll get about 70.05. Whoa, mister, that's a big difference. Yes, of course, that will be a big difference. I'm saying not to produce 200 donuts, I'm saying the exact cost to produce 200 donut. Okay, the maksudnya tuh donat yang ke-200 tuh harganya berapa sih untuk diproduksi? Itu harganya 70,05. The first donut is 10,000. And why is that? Because maybe the first donut you'll spend a lot of time for research and development. That's why you need like 10,000 and trial and errors. And it makes sense. For the 200 donuts, let's say the productions already continue, and you have like a amount of the ingredients left over, so you can have a cheaper rate, a cheaper production donuts. Okay, the cheaper producing cost, okay, which leads to 70.05. Okay, let's get into the next problem. Example 2, the total cost of producing X bicycle is given by these functions. C of X equal 10,000 plus 150X minus 0.2X squared. Find the exact cost of producing the 141st bicycle. So again, the exact cost, I don't have any symbols, yeah, for exact cost of producing the 141st bicycle, so I just write it again. Okay, that will be equal to C of 141 subtract with C of 140. So that will be 10,000 plus with 150 times with 141 and subtract with, okay, wait, minus 0.2 times with 141 square, subtract with the part of 140, which is 10,000, this one, plus with 150 times with 140 minus 0.2 times with 140 square, and that will be equal to $93.80. Okay, B, yeah, this is the exact cost to produce the 141st bicycle. Use the marginal cost to approximate the cost of producing the 141st bicycle. Now we are going to approach it. This is the exact, this is the approximations. Okay, so we use the marginal cost or the differentials. So what we need to set is the C prime of X, that will be 10,000, that will be equal to 0 of the derivative, and 150X will be 150, subtract with 0.4X, right? and then C prime of 141, that will be equal to 140. Okay, so this is wrong. 140. Why 140? Because the tangent line happened at 140 to produce the next item, which is 141st item. Okay, so 150 subtract with 0.4 times with 140, and then we'll get $94. As you can see that the difference is not much, 0.2 or you can say 2 cents. Is it correct? 20 cents or 2 cents. Okay. Now, if you questions why this is not 141, because we want to know the cost of producing the 141st bicycle, not 142nd bicycle. Yeah. So that's why it's 140. The tangent line is 140 to estimate what is the next item cost that will be produced. Okay, that's the